E já vamos imediatamente convidar a professora Andréa Rossário, please. Uma salva de palmas, gente, por favor. E como moderator, professor Kevin Moffitt.
Okay, I'd like to I'll introduce our speaker. Andrea Rosario is a PhD candidate at the Rutgers Business School, and she has a lot of professional experience as an auditor. She's a licensed CPA, and we're very fortunate she's at Rutgers and not in the workforce, and we'll hear what she has to say.
Okay, thank you, Professor Kevin Moffitt. Today I would like to talk to you about one of our new research projects at the WCARS Lab that we're working on with one of our new PhD students, Ben Yoon. The project is financial reporting regulation with big data analysis for CVM. The purpose for this project is to use financial and non-financial data, we can call this big data, and apply different analytic methodologies that can help us improve the inspection process for the Brazilian SEC, the CVM. This is the outline for my presentation. I know that my presentation stands in the way of you and lunch. I'm very sorry about that. The U.S. Securities and Exchange Commission started using big data and technology for supervision in the middle of 2013. This is the time in which the U.S. SEC started this new project initiative called the Audit Quality Model. The Audit Quality Model allowed the regulators to look at the discretionary accruals that were reported for the publicly listed U.S. companies. This is the first time that the SEC started using technology in their inspection, or as part of their inspection process. Then I would like to say that after 2014, the SEC started a new initiative, which is called the CIRA, the Corporate Issuer Risk Assessment Initiative. And actually, one of the SEC representatives calls this initiative the AQM on steroids. Now, why they call it AQM on steroids is because the regulator can not only look at the discretionary accruals, which was the purpose for the AQM, but they could also look at many different ratio analysis, which can be performed from using data analytic techniques and other machine learning methodologies. So we can see here in this table that the financial reporting actions from the SEC, issued by the SEC, increased. They doubled from 2013 to 2015, from 68 to 134. And this could be the result of the big data and the technology that they were using. And we would like to do the same for the Brazilian SEC, the CVM. This is the conceptual model that we currently have. First, we download financial statement data from Economatica to get the financial data like revenue, net income, and other important data that we can use in our analysis for the publicly listed companies in the Brazil Stock Exchange. We could also use big data. We can incorporate big data into this conceptual model, like social media and news articles and press releases. We could also incorporate big data like weather, so that we can run a regression, for example, and use it for prediction to predict the sales and compare that to the sales that have been reported by one of the Brazilian companies. And then the second phase for the model is to actually perform the analysis. We can use very simple techniques like the accrual analysis, financial ratio analysis, and then we could use data mining, more modern methodologies like data mining, machine learning. We can apply some text mining. We have Professor Moffitt here. He's our text mining guru. And then in the last phase of the model, this is what the regulator is going to see. This is the output. which consists of the fraud prediction score and the dashboard for the regulator. The fraud prediction score, it goes from a scale from 0 to 100, meaning that the higher the score, the higher the likelihood that a company is potentially engaging in some fraudulent financial reporting. And then the dashboard for the regulator, these are many different visualizations that we can use so that the regulator can improve their inspection analysis. The dashboard for the regulator can also include some time series analysis and some industry comparison, some peer group analysis with many different ratios. These next few slides are for show and tell. This is the first component of the output result that the regulator can see. So here we have the fraud prediction score. We have the score for the accounting quality model, the AQM, discretionary accruals, and we have the outlier model, which gives us a prediction score for the different ratio analysis that we can perform. And then the final result is just an average of the accounting quality model and the outlier model. Here you can see that we highlighted 6 companies, but we can add as many as we want, depending on the threshold that the regulator perceives that is the client or the firm is not a red flag, that the firm is not engaging in fraudulent financial reporting. And here we have the distribution for the fraud prediction scores. We can see that most of these firms, they do not have a high fraud prediction score, but we can see that, and it is easy to see that only a few firms, maybe about 1 or 2, that these firms will be possibly selected for inspection. This can greatly help the regulator because it's a visualization and it is very clear that only a few firms are possibly engaging in some fraudulent financial reporting. And then this is an example of the dashboard for the ratio analysis. So here we include just we include 2 different ratios, the change in the revenue versus the change in net income, and the change in revenue versus the change in inventory. We would expect that for both of these ratios that there would be a positive relationship, right? The higher the revenue, the higher the net income. And then similarly, the higher the revenue, the higher the inventory, assuming that there's a constant demand and that the firm is expecting to make more sales. Clearly, we can see that we have some outliers, which are the red dots. This means that this relationship does not hold. So this means that we have a negative relationship in which, for example, we have more revenue, but we're reporting less income. So this is something that the regulator would have to look into and determine whether this is really an anomaly and whether this is a company that should be selected for inspection, or if there is a valid reason for the negative relationship. And once again, this is just an example because we can do the same for many different ratios and many different variables. And then here we have an interactive visualization. Actually, I really wanted to show the interactive part of it because we had some files, but unfortunately I couldn't get the files to work. But we did get these nice pictures of the 3D graph where we have the change in the net income, the change in inventory, and the change in the revenue. And the purpose for this visualization is that we can include these multiple ratios that can help us examine the impact of the relationship to see whether the firm is potentially engaging in fraudulent financial reporting. So this can give us a more holistic view of whether the firm should be selected for inspection. So those were some preliminary results, but overall we expect that implementing big data, financial and non-financial data can help improve the quality of CVM inspections. Because this will allow the CVM regulator to actually spend more time in the analysis section, and they can focus on the higher risk companies. Like we saw for the US SEC, it is very possible that we're going to see an increase in the enforcement actions that are issued by the CVM. And another impact of this model can be that this can increase how companies report, right? Because companies are going to be more conservative in how they report their accruals, for example. Once they find out that CVM is using more automated approaches to be selected, for firms to be selected for inspection and in the actual inspection process, these companies are going to be more self-aware that there will be a higher likelihood that they're going to be caught because they're going to be inspected. But overall, the purpose for this model is to improve the inspection process for CVM. Okay, thank you.
Well, thank you. Obviously, the prediction models are a big deal right now, and something that Rutgers has been working on a long time, and we've seen a lot of this at WCARS. And the SEC is smart to enter this field, and we've consulted with them quite a bit here, and I'm not sure if we're doing question and answer, or are we going? Yeah.
Okay. Professor?
This is just a preliminary work. We are still just beginning on this. But I think we are convinced that we can use this methodology once working with CVM into something that be useful for them. Now the problem we find here is that the sample here is very small. Even in the US, the sample for machine learning is pretty small. And so we'll need to segment these letters, and maybe we will not use machine learning, but just focus on pure play ratio comparison like we are doing in the US in that project. So it's just don't look at those company names seriously, because this is just an illustration of how we are working. We did see OSX there, and we knew that the ratios were really off the line. So don't take it that very seriously, but it's a method that we are convinced. We are not only working on this. The SEC, SIVA don't particularly want to work with us, we don't know why, but we have actually data from Korea, now data from Indonesia, and this data from CVM, and we expect to be able to do very nice things on this. Hopefully, if they give us more discrete data, we'll be even better.
Thank you.
Uma salva de palmas então, senhoras e senhores, Dr. Kevin, professora Andrea.